world of illusion. The material world is a world of illusion that we live in. Yet still, we think it's reality. We think it's the way we sense it. I need you guys to work with me a little bit here on this one. It's a stretch. It's a stretch into the physics and the quantum mechanics and what have you, but I'll try to simplify it as best as I can. The tabletop that you're resting on, that your papers are resting on, describe it to me, please. Not only is it smooth,
Brown.
it's hard. It's hard. Actually, it's solid. I would say it's solid. Yeah.
It's brown.
And it's brown.
With black stripes. It has texture.
Homogeneous.
Flat.
Yeah.
Some have a matte texture.
Yeah. A matte texture.
Maybe a little cool.
And cool. I thought it was cool, the metallic feel, but not icy cold, like just
Has a little gold finish.
metal. Let me take a spin off of the comment that someone said it's solid. Is it really solid? What is it? Of course it's solid. She just knocked on it.
Yeah.
I can lean on it. It's solid.
I would think that'd be a relative statement compared to what?
Well, it's not solid because it's particle board.
It says Formica and glue, yeah.
There,
Wood
it's in
chips
the
and glue.
So it's not solid. Is it fluid?
No, it's solid. No.
It's solid.
At this point.
Air trapped inside it.
There's air in it, but I can sit on it. I can sit on it. So it must have some kind of solid support to it. I'm going to challenge that and tell you it's not solid. Actually, it's mostly empty space. How can that be? Let me take you on a really quick journey that you've heard before in your science class. The basic building blocks of everything is the atom. Anybody remember the structure of an atom?
Round.
You don't have to. Here is the structure of the atom. It's a cross section.
I was right, it's round.
Cross section of a 2D depiction of an atom. Let's say it is round. In the center of this atom, I've drawn a little dot. And that dot is the nucleus in the heart of the atom. That's where the protons and neutrons live. Okay? And the outside of the atom, circling and orbiting the nucleus, will be another subatomic particle called the electron. Here's the electron. And I've purposefully drawn it even smaller than the nucleus. The point I want to make here is the atom itself is mostly empty space. All of this is empty space, and all that's occupying it is a very teeny tiny dense nucleus and an even smaller electron. The distance between the nucleus and the electron is so vast that if you were to scale up the nucleus to the size of a golf ball, this nearest electron would be 1 mile away. That's how vast the distance is between the nucleus and the electron. That's how much space is relatively in an atom. So if you take a whole bunch of atoms and put them together to form a structure such as this table, and each atom is mostly empty space, that means that this is mostly empty space, right? You see that deduction? Mind is messing with me now. Okay, I follow that, that makes sense, but I sense this as being solid. I sense it, but my senses tell me this is solid. How can that be not true? How can you describe or explain this discrepancy?
There's so many atoms.
Yeah, there's something about the atom. That's right, there's something about that atom. And that something about the atom is the electron. This sweet little electron that can be so deceptive. These subatomic particles have a charge. The charge on the electron is either going to be positive or negative. Which one do you think it is? Take the other one. The other one. That negative, yeah. The charge on the electron is negative. Just remember that, all right? It's a negative charge. So if everything is made up of atoms, and the outside outside of every atom has a negative charge on it, that means the charge on the surface of this table would be negative. So here I come along and I lean on the table and I find that it is solid. Well, my hand is made up of tissues, which is made up of atoms, blah, 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 basic building block of the atom. Surface of the atoms on my hand, the charge will be negative. When you put a negative against a negative, what happens? It is polarized. It's the same charge. Do you remember back in grammar school or high school taking two magnets, putting the same end of the magnets together? What happens? There's a repulsion. Yeah, you get so close and then all of a sudden, can't get any more. It feels solid. There's a resistance. That's the same thing that's going on with the surface of my hand and the surface of the table. The negative charge on the surface of the table is repelling the negative charge on the surface of my hand. And it gives